With today's lesson, we wrap up 2.1, looking at 2.1c, negative exponents, and some word problems as well. And our goal for today is to practice simplifying powers that might have negative exponents, and we also want to take a look at powers that we might see in word problems. So there's no real new information, no real new notes to look at today. It's just applying what we've learned to different types of problems. So we're just going to be looking at several examples, and hopefully that should help you become familiar enough with how to do these problems that you'll be okay with your homework for tonight. So for our first example, we have x to the fifth times x to the negative second power. And so with these types of problems, we're multiplying powers together, and we know that we want to add the exponents when we're multiplying powers with the same base. So if we look at this, that actually ends up as x to the fifth plus negative 2. Okay, we add the exponents together, so 5 plus negative 2. We have to simplify the exponent, leaving us just x cubed. And that is our final answer for that one. Let's take a look at another one. Here we have 9 to the negative 8th times 9 to the 6th. 9 to the negative 8th times 9 to the 6th. Again, same thing. We're multiplying powers with the same base, so we add the exponents, giving us 9 to the negative 8th plus 6. And when we add those together, we get 9 to the negative second power. Okay? Now, if my HRW wants you to leave your answer like that, I'm fine with that as well. Otherwise, another way that you could write your answer, 9 over negative 2 is the same thing as 1 over 9 squared. All right? So there's a couple examples where we're multiplying powers with the same base. Let's look at some examples where we are dividing powers with the same base. So for our first example, we have 13 to the negative 11th over 13 to the negative 7th. And this is actually our fourth example. I skipped the third one. I'll go back to that one in a moment. So for this one, again, we're subtracting powers with the same base because we're dividing. So we have 13 to the negative 11th minus negative 7. The first minus sign is because we subtract the powers. We subtract the exponents because we're dividing the powers. The second negative is just because it's negative 7. Now we know that when we have a double negative like that, it becomes plus positive. So 13 to the negative 11 plus 7, negative 11 plus 7, this is why we've been practicing these problems during bell work, gives us 13 to the negative fourth power. And again, if my HRW is okay with you giving an answer like this, I am as well. Or you can make a positive exponent by rewriting that as 1 over 13 to the fourth power. Alright, so that's our fourth example. I accidentally skipped our third example, so let me scroll up to that one. Here we have m cubed over m to the 8th. M cubed over m to the 8th. Since we're dividing the powers, we're going to subtract the exponents. Divide the powers means subtract the exponents. We have m to the third minus 8, giving us simply m to the negative fifth. And again, if you wanted to rewrite that with a positive exponent, that could be 1 over m to the positive fifth power. Okay? So there's a couple examples where we're dividing powers with the same base. Now let's also take a look at a couple where we are taking the power of a power. So for this next example, we have b cubed to the negative fourth power. And we should remember from taking power of a power, whenever we take a power of a power, we need to multiply the exponents together. So that means we have b to the third, it's supposed to be a parentheses, times negative 4. b to the third times negative 4. When we multiply a positive times a negative, that turns the whole thing negative, giving us b to the negative 12th power. And again, if you wanted to rewrite this with a positive exponent, This could be 1 over b to the 12th. All right, so that's our first example of a power of a power. One more that I want to look at. Here we have 2 to the negative 9th to the negative 5th. So with this one, again, we're taking 2 to the negative 9, and we're multiplying the powers together. So negative 9 times negative 5, when we multiply those together, anytime you multiply a negative times a negative, you're going to get a positive. So 2 to the negative 9th to the 5th is going to give us 2 to the positive 45th power. All right, so that wraps up the first part of our goal, where we wanted to look at some negative exponents with powers. And the next thing that we want to do is we want to take a look at a couple word problems. And yes, I do expect you to write the entire word problem down in your notes, okay, so that you can reference back to it and see what the problem is all about. You must, when I'm going to be checking in your notes, I will expect to see the entire word problem, both word problems written down. All right, so for our first word problem, example 7, it says the distance between Earth and the Moon is 22 to the 4th. Oh, I forgot a label in there. 22 to the 4th. I think it's supposed to be miles, or maybe it's kilometers. I apologize. I should have a label in there, definitely. 22 to the 4th. Ta-da! 22 to the 4th miles. The distance between Earth and the Moon is 22 to the 4th miles, while the distance between Earth and Neptune is 22 to the 7th miles. How many times greater is Neptune's distance than the Moon's distance, that should say from the Earth? Okay, so now what we're looking for in this word problem, we see this question, how many times greater? And a lot of times when students see that question, they'll think, oh, well, times, that means multiplication. But in this type of problem, or with any word problem, whenever you see how many times greater, that is actually telling you that you need to divide. Okay? So how many times greater is Neptune's distance than the Moon's distance? That means we need to divide. And since Neptune is mentioned first, Neptune's distance needs to go in the numerator. So we're going to have 22 to the 7th over the distance between the Earth and the Moon, which is 22 to the 4th. Okay? Now, just like before, we want to simplify by subtracting the exponents. So we have 22 to the 7 minus 4. 7 minus 4 is 3, so our final answer is 22 to the 3rd. Okay? So 22 to the 3rd, many times greater. That's our final answer. Final problem, final example. It says a student claims that 7 to the negative 5th times 7 cubed is greater than 1. Explain whether the student is correct or not. All right. So, in order to help us explain whether the student is correct or not, we should go ahead and actually solve or simplify that expression. So 7 to the negative 5th times 7 cubed. We know that when we're taking and multiplying powers with the same base, we add the exponents. So we have 7 to the negative 5th plus 3, giving us 7 to the negative 2nd power. All right. Now for this one, it's important that we actually do convert this so that we have a positive exponent. So our answer here is going to be 1 over 7 squared. And 1 over 7 squared we know is equal to 1 over 49. So the question we have to ask ourselves is 1 over 49, is that greater than, less than, or equal to the number 1? Okay, so 1 over 49, we should know that that is less than the number 1. Therefore, the question up here, explain whether the student is correct or not, our answer would say that the student is incorrect because 1 over 49 is less than 1. All right? That is all the examples that I have. Again, it was just taking the concepts that we covered in our previous video and applying them to negative exponents and to some word problems. Make sure you write down any questions that you have so that we can discuss those in class further. And make sure that you have the title of the lesson and the goal written down as well.